Bringing a drone for the first time into the sky is incredibly exciting, but it's also a real challenge. Hi, I'm Kartik, a technical project manager here at CycloTech. Building a sophisticated CycloRotor system like we did with the Blackbird demonstrator took us 11 months, which is incredibly fast considering the size, manufacturing, assembly, testing, and authorization for flight and many other elements. To move this fast, we needed a better way to validate our ideas early. So our engineering team developed a rapid prototyping process for multi-rotor platforms using CycloRotors. In this process, everything is done in-house, from conception, design, and production of each component, including machining and 3D printing, followed by the assembly and testing. Additionally, we are having multiple test benches to test and validate each configuration before our first flight. Having all these capabilities within our company allows us to build faster, make modifications on the spot, and rapidly explore different platform configurations using CycloRotors, all in a matter of weeks. One of our first prototypes was a 6-rotor configuration, resembling the configuration of the Blackbird, just in a smaller scale. However, what's important, it actually uses the exact same flight control system as the Blackbird demonstrator. That means we can ensure that the control logic, algorithms, and system behavior remain directly comparable, giving us the opportunity to verify design assumptions, validate rotor performance, and reduce development risks before taking the Blackbird demonstrator into the skies. That helped us achieve the success of the Blackbird demonstrator in a stellar timeframe. Currently, we are working on a 4-rotor drone configuration. With this platform, we can test multiple flight modes like altitude hold, velocity control, and position control, while analyzing key performance metrics. Collecting all this valuable data gives us a broad insight into the performance capabilities of our CycloRotor system. This allows us to offer aircraft configurations which have not been developed before and enhance the performance of any aircraft solution, be it a drone, a flying car, or as a support system for existing platforms. Having this capability and engineering expertise allows us to validate and test design assumptions and gather high-quality data. These insights, learned at a small scale and efficiently applied to large rotor systems, accelerate our development while reducing risk. With this, we are unlocking a completely new breed of mission adaptive platform using CycloRotors. All of this is made possible by exceptional teamwork and collaboration. We learn from our setbacks, continuously adapt and improve, and ensure that CycloRotors are ready for real-world deployment.